Welcome to this mini tutorial on simultaneous equations involving non-linear problems. So here we have x squared plus y squared equals 13 and 2x plus y equals 4. In this instance we're going to use a substitution method rather than elimination. So I will have, call that 1, call that 2. Equation 2 I rearrange and I can get y equals 4 minus 2x. So in doing that I can substitute 2 prime, which is my new equation, into 1. That gives me x squared plus, instead of y, 4 minus 2x all squared equal to 13. So then I expand x squared plus 16 minus 8x minus 8x again, so I've got minus 16x plus 4x squared equals 13. Like with any quadratic, we want to have a look at it, equal to 0. So I've got an x squared there, 4x squared there, 5x squared. I've got minus 16x, so I've got, and I'll bring this 13 over, subtract it from 16, I've got plus 3. I'm going to play with this a bit, see if it factorises. Just a reminder, so I'm going to think, well, 3 times 5 is 15. I need something to multiply to 15 and then add to make negative 16. That's 5 times 3 is 15. This helps me a little bit. And what I get is negative 15, negative 1. That means I can split this 16x into negative 15x and negative 1x. It's another method of factorising. It's a little strategy that helps you factorise these more complicated quadratics. So 5x squared minus 15x minus 1x plus 3 equals 0. Hopefully you can see how this is going to fall into place. So 5x is common to those. 5x, x minus 3. And then here I've got an unusual one, minus 1x plus 3. It might be difficult to see what to do with that. I want to make x minus 3 really. You can see that from there, and you've got a 1 and a 3, one lot of x and a 3. So I put take away minus 1, lot of x minus 3. Minus 1 times minus 3 is my positive 3 there. Those ones are sometimes difficult to spot, but it comes like anything with the practice. So 5x minus 1, I pick that up from there and there, multiplied by x minus 3 is 0. Well, that gives me two solutions. It gives me x equals a fifth and x equals 3. Now, because this is a quadratic problem, we've got a pair of solutions. The simultaneous equation has 2 pairs of solutions. So I'm going to take, well, x equals 3. There we go. That's going to go with y equals 2. Because, or y equals minus 2, sorry, negative 2. Y equals negative 2. And how do we find that? Well, we look back at our second equation. 2 lots of 3 plus something equals 4. Well, when x is 3, that's 6 plus something equals 4. It's got to be negative 2. So I've got one pair of solutions. My other pair is a little bit trickier. It's going to be well, when x equals a fifth, I think back and I look, well, 2x plus y equals 4. I'm dealing with fractions, so I'm going to be a little bit more careful. So I think, okay, 2 lots of x, that's 2 fifths. Yep. Plus something equals 4. Well, let's imagine that's expressed as 20 over 5, which is still 4. Well, pretty quickly I can say, okay, 18 over 5. So my other solution will be 18 over 5. So x equals a fifth and y equals 18 fifths is your other solution. Now, you might want to put these back in to the circle equation there to check it. And that will verify your answer. But just a quick review, here we're doing a substitution. So we're substituting the rearrangement of our second equation into the circle equation at the top. And we expand, simplify and solve as a quadratic. Hopefully that example has been useful. It might be worth you practicing some of those.